Have you ever gazed up at the night sky and wondered about the size of the stars you see twinkling back at you? Our universe, a magical expanse of time and space, is home to countless stars. These celestial bodies, scattered across the cosmos, vary incredibly in size, from the modestly small to the incomprehensibly large. The night sky, a canvas of twinkling lights, has always stirred a sense of wonder and curiosity within us. Each star, a world unto itself, poses a multitude of questions. How big are they really? How do they compare to our own sun? Our fascination with the cosmos is as vast as the universe itself, an unending quest to comprehend the mysteries that lie beyond our earthly confines. Understanding the size of stars gives us a glimpse into the grandeur of the universe, a spectacle that never ceases to amaze. Today we're going to explore the size of stars, from the smallest to the largest. The smallest stars in the universe are fascinating, and they're called white dwarfs. These stellar remnants are the final evolutionary state of stars like our own sun. When a star has exhausted its nuclear fuel, it sheds its outer layers and leaves behind a hot core, which we call a white dwarf. These tiny stars are incredibly dense. Despite being similar in size to Earth, a white dwarf can have a mass up to 200,000 times that of our planet. It's a bit like packing an elephant into a suitcase. Their life cycle is equally intriguing. After their fiery birth, white dwarfs cool and fade over billions of years until they become black dwarfs. However, the universe isn't old enough for any black dwarfs to exist yet. So, while they may be small, white dwarfs have a big story to tell. While small in size, white dwarfs hold a significant place in our universe's stellar landscape. But what about the larger stars? Moving up the scale, we encounter stars like our own sun. This celestial body, the heart of our solar system, is considered a medium-sized star. To put its size into perspective, imagine 1 million Earths. That's how many could fit inside the sun. Its life cycle is a fascinating journey, starting as a nebula, evolving into a main sequence star like it is now, and eventually transforming into a red giant before ending as a white dwarf. The sun's influence reaches far beyond its size. It's the reason life as we know it exists on Earth. It provides the warmth and light necessary for survival. But our sun isn't alone in its category. There are countless other stars of similar size scattered across the universe, each with its own unique story. While our sun is immense compared to Earth, it is merely average when it comes to stars. So, what's next? Now let's venture into the realm of the truly colossal, the giant and supergiant stars. These celestial titans are the heavyweights of the cosmos, dwarfing our own sun by hundreds, sometimes thousands of times in terms of volume. They come into existence when medium-sized stars, like our sun, have exhausted their hydrogen fuel, causing them to expand massively. The outer layers puff up like a cosmic balloon, and these stars become giants. Their life cycle is a spectacle to behold. From their birth in nebulae, these stars live fast and die young, their lives marked by dramatic changes and explosive ends. Their cores collapse under gravity, triggering a supernova explosion that disperses the star's enriched material into space. This material then serves as the building blocks for new stars and planets, a cosmic cycle of death and rebirth. Let's take a closer look at some of these giants. Betelgeuse, for instance, is one of the most well-known examples. A red supergiant, it's so large that if placed at the center of our solar system, it would extend beyond the orbit of Mars. Another example is Antares, the heart of the Scorpius constellation, a red supergiant that outshines our sun by a factor of 10,000. But these stars are more than just celestial spectacles. They play a crucial role in the universe. In their fiery cauldrons, elements heavier than helium are created. This process, known as nucleosynthesis, is responsible for creating most of the elements on the periodic table. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were forged in the heart of these stellar giants. These stars are truly awe-inspiring, but there is one star that outshines them all in size. Finally, we arrive at the largest star currently known to us, UY Scuti. Imagine a star so colossal that if placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. That's UY Scuti for you. In comparison, our sun, which seems an astronomical giant to us, would merely be a speck of dust. UY Scuti is approximately 1.5 billion kilometers in diameter. To put that into perspective, if you were to travel at the speed of light, it would take you about 7 hours to circle it once. Compare that to the mere 14.5 seconds it would take to do the same around our sun. When we delve into the life cycle of such a titan, we find it's quite turbulent and ironically short-lived. UY Scuti is a red supergiant star, a stage that stars reach towards the end of their lives. It's currently in a phase of rapid expansion and cooling. Once it exhausts its nuclear fuel, UY Scuti will shed its outer layers and collapse into a white dwarf, leaving behind a nebula, a stunning cosmic work of art. Measuring such a vast star is no small feat. The distance, the star's pulsations, and the surrounding dust make it a challenge. But the enigma and fascination surrounding UY Scuti make the endeavor worthwhile. It's a testament to our curiosity and the lengths we'll go to understand our universe. From the small but fascinating white dwarfs to the mind-boggling size of UY Scuti, we have journeyed through the universe's stellar extremes. Contemplating these celestial bodies, their life cycles, and their sheer scale gives us a fresh perspective on our place in the cosmos. The night sky will never look quite the same again, will it?